Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So this is part third video of the magnetism and matter. So today I am going to discuss few topics that related to this magnetism and matter. So let us discuss. So first topic is where we will discuss is the magnetic field on a axial line of the axial line of the magnet. So let us consider this is a magnet. This is your magnet, and I want to find a magnetic field at a point which lies in either side of the axial line. Axial line, see, if you if you want to find what is axial line, so whenever line crossing like this, that is horizontally, so this is known as axial line. This is known as axial line, right? And a line which is passing through like this perpendicular at a center, it is known as equatorial line. Equatorial line. Now I want to find a magnetic field at any point which is placed at a axial line. So we will do this. Now let us suppose there is a point. Let us suppose there is a point P which lies on the axial point. Okay, and we know that this is a magnet. This is a magnet, and we want magnetic field at a point P due to this whole magnet. So let us consider this side there is a south pole, and this side there is a north pole, right? And this is the center of the distance between center of the magnet and P is, let us suppose this is your D, and the length of the magnet is 2L. So definitely this length will be L. Okay, now what we can do, we need to find a separate magnetic field due to each of the pole, either north and the south pole. Now we know that the magnetic field has a formula mu naught by, m by 4 pi r square. So this is the proper formula for the magnetic. So where r is the distance from the magnet. Now here see, I want magnetic field. So you know that this is a north pole. So due to north pole, magnetic field is directed toward this direction, and due to south pole, magnetic field is directed toward this direction, right? So net magnetic field will be b2 minus b1. Now how you will find a b1 and b2 separately? Let us say if we talk about b1, so that is the magnetic field due to south pole. So what you will get, we have a formula mu naught by 4 pi into magnetic pole strength is m. And what is the r? So r is the total distance. So let us suppose this was the distance d. So from here this distance is also L, because it is the half of the magnet. So it means that it is your d plus L. So we can put r in place of r, we can put here d plus L whole square. So finally we have got as a magnetic field b1, right? And this b1 has a magnitude which is in this direction. Now let us suppose magnetic field strength b2, and there is a b2 due to north pole. So due to this pole, so what is the distance between these two? So definitely whole is d and this one is L. So definitely this distance will be d minus L. So now if you want to find particularly the magnetic field b2, so b2 will be equal to mu naught by 4 pi m by d minus L whole square. Okay, so finally we have got b1 and b2. Now let us find a net magnetic field. So this will be equal to b2 minus b1. So we will do some of the calculation here. So if we so the magnetic field strength P due to the bar magnet is B is equal to B2 minus B1. So here we will put the value B2 is equal to mu naught by 4 pi m by d minus L square minus mu naught by 4 pi m by d plus L square. As soon as we will collect it, so mu naught by 4 pi into m 1 by d minus L whole square minus d plus L whole square. So finally if we calculate it, so what you will get, let us check it. So this will be mu naught by 4 pi into m into d square plus L square plus 2dl minus d square minus L square plus 2dl divided by d square minus l square whole square. So this got cancelled out. So finally this is your 4dl. Okay. So I hope you have understood this. So you can do it yourself also. So finally we have got mu naught by 4 pi into m into 4ld by d square minus l square l square whole square. Okay. So this is the magnetic wave. Now tell me, what do you mean by 2lm? What we have studied, 2l into pole strength. So pole strength, suppose this is a magnet and it is pole strength, this is your pole strength, and the distance between these two is your 2l, and pole strength is m. So dipole moment, magnetic dipole moment will be equal to magnetic pole strength m into 2l. So in place of m into 2l, we can put here m. We can put here m. So definitely we can write like this. See here. We can write here. Right here. This is equal to mu naught by 4 pi into 2l into m into d into 2 by d square minus l square whole square. So what do you observe here? 2lm. So 2lm is equal to, we can put here magnetic dipole moment, that is m into d. So finally we have got magnetic field as mu naught by 4 pi into 2 m d by d square minus l square whole square. Now you have understood this. Now when the magnet is short, so if magnet is short, so it is very short, so what will happen? Let us consider this distance is very large. So it means distance square will be very larger than l square. So we can, what we can write here, we can ignore l square tends to 0. So finally our equation will become, see here, finally our equation will become, see, our equation will become mu naught by 4 pi into 2md divided by d square whole square. So finally, our equation will become like this. Okay. Now, if you cut d square d to the power 4, so finally we are getting magnetic field as B is equal to mu naught by 4 pi 2m by d cube. So at any point on an axial line of a dipole, magnetic field strength B is along m. So B is along, always along m. What is m? Direction of a dipole moment. It is always toward, it is always from south to north. So I hope you have understood this. Now next is your magnetic field on an equatorial line of the bar magnet. So we have already studied what is equatorial line. So let us suppose this is a bar magnet and the plane perpendicular to this is known as equatorial plane. So at this plane, at any point, if you want to find the magnetic field, so how you will find it? Okay. So let us draw the diagram first of all. I have already drawn the diagram. Let us see here. See here, this is the magnet. This is a magnet having a pole strength M. Okay. And this is the central axis. And this is the line at which we want to find a magnetic field. Let us suppose we want to find a magnetic field at a point P. Now we have two pole. How many pole? Two pole. That is north pole and south pole. Okay. So this is this distance. This distance is your L. This distance is also L. Now let us suppose we are considering this as a P. This and the distance between the magnet and the point P is your D. Now we can say that this length, that is between P and this north pole, it will be become D square plus L square. So this will be also become D square plus L square. So this both distance will become D square plus L square. Now the thing is that if you want to find a magnetic field, field at a point P due to North Pole. So let us suppose due to North Pole we want magnetic field. So magnetic field due to North Pole will be B1, and this is equal to mu naught by 4 pi into m by d square plus L square. So this is directed toward this direction. Now, if you talk about why this direction, let us consider this is North Pole. So you know that the magnetic field will go out in the direction, go away from the North Pole. But if this is your South Pole, so South Pole, the direction of magnetic field will be inward. So I am taking this as an inward. So finally, B2 is due to the South Pole and B1 is due to North Pole. So the direction of B2 is equal to same, but what is the formula? Mu naught by 4 pi into m by d square plus L square. Why d square plus S square? Because the distance between these two is equal to root under d square plus L square. So I hope you have understood this. Now what we have observed that the strength of this one is both one is B1 and B2 are equal. B1 and B2, strength of B1 and B2 are equal, but one thing is that both are in different direction. So B1 is in this direction and B2 is in this direction. Now if we break this into horizontal and vertical components, so what you will get, let us suppose this is angle theta, this is angle theta. So if this is theta, so this is theta, so definitely this will be theta, also this will be the theta. Okay, I no need to explain here about each and everything, but you can understand that why this is angle theta. It is line parallel, this is the parallel, so this will be alternate angles. Okay, and this is alternate interior angle, so this is alternate interior angle and this is your corresponding angle, we can say it. Okay, so this is angle theta. Now if I want to break the component of B1. So first of all, I will break a component B1. So this is angle theta. So this direction B1 cos theta, yes or no? And above it will be B1 sin theta. Now again, if you want to break the component B2, so B2 has a component B2 cos theta, and in this direction B2 sin theta. Now what you have observed that B1 magnitude of B1 is equal to B2. So in place of B1 we can also write B2, and in place of B2 we can write B1. So finally what you observe at this point, they both are in opposite direction. If they both are in opposite direction, so what will happen? They will cancel each other. So magnetic field will cancel each other. So if magnetic field will cancel, so what component we have? Now we have only horizontal component. So finally, net magnetic field at a point P is equal to P1 cos theta plus B2 cos theta. Now we know that B1 is equal to B2, any value you can put here. So we can write here 2B1 cos theta, 2B1 cos theta. Now the thing is that 2B1 cos theta, we have got it. Now put the value of cos theta. How you will put the value of cos theta? Let us check here cos theta. Cos theta is equal to, let us check here what is cos theta. Now cos theta is equal to, if this is theta, so cos theta is equal to base by hypotenuse. So this will be equal to, base is your L, hypotenuse is your root under d square plus L square. So in place of cos theta we will put here, so finally 2 into B1 is equal to mu naught by 4 pi into m by d square plus L square into cos theta means L by root under d square plus L square. Now finally if you will solve it, so what we will get here? So we can also get the equation like this. See here, net B will be equal to 2 mu naught by 4 pi m L by d square plus L square to the power 3 by 2. Okay, so finally we have got the variation. So here see, we have got this equation. So I have already derived this equation. Now one thing is that if length is very much smaller, then L square will be also very much smaller than d square. So finally we can ignore this L square to the 0. So if you do this, so finally this equation become what? B is equal to mu naught by 4 pi into m by d cube. So this is the final equation. If you ignore, if you consider a magnet is very small, magnet is very small, Otherwise, you have to put very small. Otherwise, you have to put all the things similarly. So any point on the equatorial line, magnetic field strength is the direction of opposite to the magnetic field, magnetic moment. What do you mean by this? See here. As per as per the diagram, you know that the dipole moment, the magnetic dipole moment, that is capital M has a direction. Capital M has a direction. Let us suppose capital M, it has a direction is from south to north pole. But what you observe, net magnetic field is coming in this direction. So both are in opposite direction. So hence we can say that any point on equatorial line, magnetic field strength is in the direction opposite to the magnetic dipole moment. M is your magnetic dipole moment. Magnetic dipole moment. I have already taught these things in a previous class. Okay, you can go to the previous video so that you can watch your magnetic dipole moment. Okay, so I hope you have understood this. Okay. Now, current loop as a magnetic dipole. So we will discuss this in a next part. So till now, it's okay for you today. Thank you.